Day 12 notes. The objective, to find an equation of the derivative of a function as a limit of the difference quotient. I'm going to try to break this into a couple videos because it's going to be pretty long and we'll see how we do. So the difference quotient. First look at the derivative. So we started looking at this. So if I have some function f of x, and what I want to do is I want to draw some points on f of x, and let's do that. Okay, so I have some point x. So on the function, or some x value that we're going to call x. So this point is x f of x, and then I go h units above point on the x-axis, and that's going to give us x plus h. So on the function, so this point has an x coordinate of x plus h and a y coordinate of f of x plus h. All right, now through any 2 points we can draw a line. So I'm going to draw this line right here, and just like when we were working with circles, that is known as the secant line. Now let's look at what this first question asks us. So we have the secant line going through 2 points, and this is, what does the expression f of x plus h minus f of x all over x plus h minus x represent? And then what does this expression simplify to? So let's see if we can take a guess at that, and I'll write it down. Hopefully you see that this is the slope of the secant line that's right above. So change in y, f of x plus h minus f of x in the numerator, all over x plus h minus x. So that's change in y over change in x. And that's going to simplify to this, which we talked about a few weeks ago when I gave you that difference quotient, because it came up on a couple problems. Now let's look as h, the distance between the x values, x and x plus h. So as this h value approaches 0, what's going to happen to this secant line? And let me draw that up there right now. And what we're going to see, so as x moves this way and x plus h moves this way, there's going to be an infinite number of secant lines until finally there's just one line that touches the function at one point. And what's going to happen is this is going to become a tangent line. So again, as h approaches 0, the secant line becomes a tangent line. Now the next question says, so what does this whole thing represent? The limit of the function, which is we're calling the difference quotient, f of x plus h minus f of x all over h as h approaches 0, and this ends up representing the slope of the tangent line that is parallel to the secant line pictured above. And again, just a reminder, secant line is going to intersect at 2 points, and the tangent line is only going to intersect at 1 point. And again, all parallel lines' slopes are equal. So let's take a look at this example. So suppose we're given a function, f of x equals negative x squared minus 4x plus 1. Let's find the limit of f of x plus h minus f of x all over h as h approaches 0. So why don't we do that now? I'll do the first step, show you, then we'll see if you can finish it. So f of x plus h, every place I see an x, I'm going to substitute in x plus h. So there's the first part. Minus f of x, that stays the same, all over h. So take a few seconds to see if you can simplify it and see what happens, and if we can get to a point where we can just substitute in 0, use direct substitution for our limit. So after the first step, simplifying the numerator, this is what I get, and I see I have some like terms that I can cancel out. X squareds are going to cancel out. Negative 4x with a positive 4x are going to cancel out. And positive 1 with a negative 1. So I say I get negative 2xh minus h squared minus 4h all over h, and I see I can factor out an h. Beauty of factoring out an h is I can now cancel those h's, common factors, and now there's going to be, the limit will not be undefined if I substitute in 0. So let's do our substitution. Every place C and H, so let's substitute in a 0, and hey, see what I get. Negative 2x minus 4. And we just said, what does that represent? That represents the slope of a tangent line. So let's look at what our original function was, negative 2x squared, excuse me, negative x squared minus 4x plus 1, and we got negative 2x minus 4. Soon we're going to find relationships, and hopefully you're thinking about that. How could I get from this original function f of x to this, what we're calling the slope of the tangent line, and we have a name for it. It's going to be the derivative. How I can go right from the function to the derivative. And I just started talking about it. Your result to the previous limit is defined as the derivative f prime of x of the function f of x. So let's see what this derivative represents in terms of the graph of f of x. And let me write down how we say that. As I said, that's f prime of x, and that's the derivative of f of x.